Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, May 5th, 2026. Tonight, we will do our normal presentations and then open it up to any questions from the floor. A couple of announcements before we get going. So the DPRG is holding our Robo Rama 2026. Set to take place at the Dallas Makerspace on Saturday, May 23rd. Events include Quick Trip, Line Following Advanced, Barrel Racing, 6-can, 4-square, and Sumo. Bring your robots or just bring yourselves and come enjoy the event. The other one I have is Texas Robot Combat. Robot Rodeo 2026 will take place Saturday, May 30th. Fighting open ants, plastic ants, and open beetles, I guess, are the competitions. Free for all ages of the public. Fighting starts at 10:30. Be there for early for the best seating. And that's hosted by Rev Robotics in Carlton, Texas. That's it for my announcements. First up for presenter, we have Mike.
Okay, so I'm still trying to get ready for Robo Rama, and I tried 4 corners and it seems to be pretty good. Still, I don't know if I can beat Scott like I didn't beat him last year, but I'll give it a try. And but what I wanted to present was I was working on my my Lidar motion compensation. I still say it doesn't seem like it's as good as it could be or should be. So I've been working on it for angular compensation and linear compensation. Like linear is, like basically when it's moving forward, then the distance of the Lidar has a little motion error because you're moving and scanning at the same time. And the same thing when you're rotating angularly, it has that same issue. So a different issue, but it's a different way to correct for it. So I guess what I'm going to do for a presentation is I'm going to share my Foxglove screen so I can play back my Ross bags so I don't have to do anything live.
I thought Chris did something like that. I kind of wondered if that would be, is it linear when you're turning, or is linear kind of like a first approximation of?
Well, linear means he was just moving straight.
Linear is just moving straight. So I break it up into a moving straight, forward and backwards for quick trip, and then I have some buttons on my controller where I can just have it rotate without moving forward or backwards. So I'm trying to separate the linear motion correction from the angular motion correction. So I guess so.
But is yours a spinning LiDAR, or just remind me what you have?
Oh, spinning LiDAR, yeah. Yeah, so what I'm going to do is I'm going to bring up some bags just for show and tell. Go on, menu, come up. Oh, okay, it's I can always forgets. Okay, so it's on my Samba share drive, and so I'll play the unfixed linear one right here. So it takes a while to load it up because it's loading it over the network. And so this screen here is showing you the linear velocity, and then it's plotting some angular stuff. Yeah. So when I'm running my wheels real fast, I get some slipping, and so that little dip right there is some kind of a wheel slip, and it causes a angular error because the robot sort of goes and then is crooked sometimes. So this is going forward, going backwards, and then I repeat the quick trip and repeat it. And so so it's going to go from here to here and back. And then on this screen here, the green line is the fixed scan, and then there's a red dots under it for the unfixed scan. So I'm just going to, so this is like before I try to do any linear fixing. So you can see that on the backwards, the red lines and the green lines separate when it's moving. Yeah. On the sides, they don't separate, at least in the Y direction, because there's no motion in that direction. So I don't compensate on the sides. I just compensate the vectors that are forward and reverse. So you can see that the green line here stays pretty stable in its relationship on the map, and the red moves. Well, this is supposed to be unfixed. Let's see what's going on here. Did I have? Okay, it stopped. So let's pull up the other one. Come on, you can do it. Oh, my computer's slow. Okay, because of the I'm sharing the network to the with the video here. Okay. So this is the file that I said was fixed. I wonder if I got them backwards. I'll find out. Yeah. So it's trying to do the plotting again. Yeah, because my setup here is I got a Wi-Fi connection to my robot, and the robot's connected to my home Wi-Fi. So it's getting loaded down. So I guess that's why it's running relatively slow, loading the data in. I didn't copy the files over. I'm just reading them from the drive on the robot. It's getting slow. Come on. I guess while it's doing that, I can run the other one. So I'm going to try to run this one. It looks sort of the same. But the trick is the it's trying to catch up here. So the green line is the compensated, and you can I'll start over again here while it's loading. So you can sort of see, you can see here that the red line gets distorted. Like in the back here, you can see the you can see the big gap in there where red line goes there and then jumps down. Mm-hmm. Well, the LiDAR starts spinning in the back and goes around. So that's why there's a big error. And so start that again. So
you have a recording from the robot rotating?
Yeah. Yeah, so this is just the linear translation. So you can see that like I was saying, the red line has a big jump in it, and the green line is not as big of a jump. And so what happens is when it's spinning, it gets the data, and then the data at the end is off by 100 milliseconds. And if it's running at 1 meter per second, that's 100 millimeter. So 10 centimeters. So that's a tenth of a meter. So that's why the jump is there, and the green line is a lot more stable. So and up here you can you can see that the green basically stays and the red moves in the front. So I think I've compensated the linear motion okay. But like I was saying in here, if I turn off that, you can see that I think my wheels are slipping and it doesn't slip when it goes from 0 to forward and then 0 to reverse. There's a different slippage on there, and it causes the robot to rotate a little bit. So that's like, ideally, this is the odometry, the angle that it's recording, and then the other line that's noisy is the angular velocity that it's recording from the wheel encoders, and then it integrates that and gets the blue line to get the actual angle. So somehow my two wheels, when I go forward and reverse, one of the wheels slips when it's going backwards and causes a big angle jump. Oh well, but that's a mechanical thing. Okay, so then if I go to yeah, I guess it's gonna do this again. Okay. So let's do what I believe is the angular compensation fix. Okay, so something's starting to come up. Okay, so the light blue line is the angular velocity, and the darker blue line is the integrated velocity, which gives me the pose, the direction, the angle direction. And then the purple line is the linear. So it's like the linear is supposed to be 0, but because of some wheel slippage, it's not perfectly 0. Come on. It wasn't as slow when I wasn't doing the video. Yeah. But it was never really fast anyway, but this is a lot slower than it is when I'm not doing the video. So, okay, so then let's see if we can do something here. So when I do angular, all kinds of stuff moves around, and I think that's like a time stamping error or something, but you can see that the red and the green sort of is separating. So I'm modifying the data, I think. Another thing is, and I haven't teased it out yet, is when I create a fixed scan file, like motion compensated scan file, I change the timestamp. I timestamp it at the end of the scan, and the Lidar library, when it's getting the raw data, timestamps it at the beginning. And I thought timestamping at the end would help to get a shorter delay. And I just compensate it so that when I'm at the end, I'm having no correction, and I'm compensating everything at the beginning of the scan. So okay, so over here, I'm doing the opposite, starting to do the opposite rotation direction. So I'm not sure how good this is in terms of showing the, but you notice here that the, if you trace the back, you can sort of see like the back of the robot is where the scan starts and stops. It's hard to see in rotation. It just moves too much. But there is a difference between the fixed and the non-fixed, and I believe that it's good. So I'm going to go and stop sharing. Oh, well, was any questions about this before I show the little snippet of code that does this?
Well, yeah, my question, I don't know if you can hear me, my network is unstable. It says, so is this your own algorithm?
Yeah. I was doing some Google searching and stuff, and I couldn't really find anyone that fixed it and explained it clearly. So I'm going to stop sharing this and show you the couple lines of code that does it. So stop sharing. Let me reshare my visual code. I think that's it. Nope, that's not it. Okay, let me try it again. Oh, there it is. It's VS Code right there. Yeah, yeah, that's it.
We're not seeing anything. Oh, there it is.
Yeah. And let me try to blow it up a little. Okay, so the line of code, like for the linear, well, first of all, let's do the angle because it's relatively simple. In the angular rotation, okay, if I go here at the very beginning, from the scan data, I extract some of the variables like the minimum angle, the maximum angle, and the angle increment, and the ranges and the number ranges and the scan time. So I use that information to do the correction. And so when I go to the angular correction, So the angular error, see, where's angular error? Oh, come on. I'm sorry, I'm moving it. I'm giving everyone crazy. Okay, so here's it. So what happens is while the robot rotates, the scan angle increments and decrements, and so here's the angular error. So this is how much angle error, like when it's spinning. The robot's spinning and the Lidar spinning. When it does a complete Lidar spin, there might be a gap in the angle, so it's not a full 360 degrees. And if it spins the other direction, it's more than 360 because they overlap. We've got a good drawing of it. But so what I have is the angular velocity times the scan time is my angle error. And so the way I fixed it is I changed the max angle to subtract out the angle error. So it's gonna change the maximum angle. And so in one direction, like normally A max is plus pi and A min is minus pi. That's typical. And so over here, I would subtract angle error from plus pi. So I go from minus pi to plus pi minus the angle error. And then that changes the angle increment for every sample by A max minus min divided by the number of ranges. And so that's basically getting the angle error. And then the thing is, all I do now is I just copy in to the output message for the fixed scan data. I copy my new max, my new min, and my angle error. So that's the entire angular velocity fix is changing the angular max from pi to pi plus or minus the angle error, and then computing a new increment because it's not the same angle every step that it changes. Like in the scan data, it says here's the number of ranges, and well, the range count is 720, I believe, on this one. And so it takes 2 pi divided by 720 is the normal one. And when you adjust the max, then the A increment is going to be plus a little bit or minus a little bit. And that's how and it's embedded into the scan file, the laser scan file. And so I guess if you looked at, we didn't look at it, but I remember looking at when it rotates, the green line has a gap in one direction and has an overlap in the other direction. It's a little hard to see, but that's sort of the correction. And then the linear correction is the distance error, which is linear velocity times the scan time. So that gives me the distance error in meters. And then I was thinking that since I know the linear acceleration, etc., I could tweak it and get a little better, but I didn't seem to do much, so I just took it out to make it simpler. And so for each of the ranges, sorry, I generate a curve first, a linear correction curve, and the big thing is, one of the things is I create a list of values for a line that goes from 0 to 1, incrementing for each of the scan data values. And then my distance adjust is the absolute value of that 0 to 1 times the cosine of just computing the cosine along that line. So this is computes a cosine. So the very beginning of this curve is 0, and then it has a little curve, and then at the very end it goes up to a 1 for the end of the cosine. So it's basically a cosine that's modulated with a 0 to 1 line. It's basically so that when the line is 0, it doesn't do any correction, which is, I believe, the end of the line or something. But and then at the other end, it does a full correction of the adjustment. And so the linear is basically adding in that distance error that I calculated times a point on that linear curve. And then this is something I need to look at so I thought it would help to set the time scan to the end, because that's where I didn't do any correction. And I could change all the code and set the timestamp to, or not change the timestamp, because this is the timestamp from the raw data from the Lidar, and then I'm adding a scan time to it. So it's just, it's just setting it one scan time later, so which is basically the end. And I didn't know how to do math with time objects in ROS, so I just did that, and then I said if it overflowed, then I increment seconds and subtract 1 second from nanoseconds. That's the way I did it. I was looking
question.
For
The question is, so are you factoring your encoder information into this equation at all?
Oh, well, the encoder gives me well, I'm getting from my odometry, I'm getting the linear velocity in the x direction, and that's done in another function, and it's setting a variable here because the scanner and the odometry are not synchronized. So this is basically a sample of what's going on.
But you're not, are you taking into account, so just velocity and linear and angular velocity, or also kind of what's your robot's pose at a given point in time?
No.
Sounds like your algorithm is based on, okay, so I'm moving at a certain speed, let's say linear. I expect that to translate into a certain type of error, and so I'm gonna just compensate for that based on my speed.
Right. Yeah. So the robot is, I just look at the linear velocity and the angular velocity at a point in time, and I was thinking, since the robot's moving, I could use the linear acceleration and the angular acceleration to try to compensate for where the robot is at any moment in time while it is rotating. But I didn't do that. No. It's on my to-do list to say, hey, try to figure out how to do the while the robot is rotating and the scanner is rotating, try to figure out how to change the basically what you're saying is a pose. So, or is that true? No. Oh, I was thinking that the linear velocity and the angular velocity could be changing while the robot's rotating. Otherwise, it's a static thing. And if it's perfectly flat and static, then it's good. But when you saw the plots on there, you saw like the plots and stuff were not perfectly straight lined. So,
with all that compensation in place, sort of, are you seeing an improvement in your navigation, or what is it improving for you?
I did this for barrel racing to try to increase its speed, and because basically it's trying to measure the distance to the barrels, and I'm doing it. And during barrel racing, I'm actually dynamically finding the barrel and then trying to keep a certain direction while I'm whipping around it and coming out the other side. And it before I did it, I could only get like 0.2 or 0.15 or something like that linear velocity. And after I did this, I could bring it up to about a half of a meter per second, 0.5. And it was still going around the barrels, but going fast around the barrels and not losing control. So I tested it, and it said, "Hey, it's improved it." and then I did those ROS bags to try to capture the data to display what's going on, so I can see if I can do better. see if I can see any faults in it. But just I could get barrel racing to run a lot faster with this correction, without ramming into the barrels accidentally. You're not supposed to do that. So that's my my presentation for what I'm doing without any nice pictures or anything for motion compensation of my LiDAR.
I put a link in the chat to what I did a couple years ago, which I just called it dewarping instead of motion compensation, but it's trying to solve the exact same problem. So, is it okay if I share my screen for 1 second or like
Yeah,
a minute?
go ahead and take it over. I'm finished.
Just let's see.
I'll stop. Okay.
Just because it's related. So let me just entire screen. I don't know if I'm doing this right on my Mac. Can you see my screen?
Yeah.
Okay. Yeah, so here's just a picture of this is what the LiDAR sees, right, when the robot's stationary. So this is what the good data is supposed to look like. Okay. Now, what I found is linear motion wasn't causing as much of a problem. I was primarily seeing an issue with the angular motion. And in my situation, when I was using the RAW's navigation stack, it was just completely getting confused by all this warping that's happening. Again, not so much by linear motion, which of course creates exactly the kind of picture you showed, but things weren't getting confused by that. But angular movement, right, or just turning in place, kind of warps the whole picture this way. Okay, so this is what the scan looks like when the robot's turning in place. Right, completely like warped, right? And so my attempt at dewarping that, so yellow is the bad scan, white is the corrected scan. So I did a decent job. It looks it did a decent job. I still found that the navigation stack, and I forgot what I was using, which SLAM method there, but it was still getting confused by the artifacts that were getting created by the motion. So in the end, it was good, but just not good enough really to make a real dent into things. So at some point I put it aside, but I just wanted to point that out. The link is there. My approach, yeah, it was basically taking what I was doing is for every point that the LiDAR was sensing, right, I was trying to do math on, okay, what point in time does that sample correspond to, right? We get, let's just say 360 samples. At what point in time was a given sample taken? And what was my robot's pose at that point in time, so that I can then basically adjust that sample to take into account which way the robot was facing, or at that point in time. So I think the math is sound, but again, the improvement was, let's say only 80% of what it had to be for this to make a big difference for me, unfortunately. It's been bugging me. I'm always thinking of revisiting that, so I'm glad you brought up your solution. It's bugging me why it's not better. It's not doing better than it's doing. I don't know if I'll have time to revisit this, and it's but it's been bugging me that it's just not doing as well as I was hoping it to do.
Yeah, because like last year on 6CAN, I could never run very fast without just doing bad stuff, and I'm using the navigation stack for 6CAN, and so I got all the cans, but I was slow, and Scott beat me. So
yeah.
So
the other thing I ended up doing,
I can run faster.
I probably mentioned that before because again, it wasn't dealing with the rotation good enough. I ended up just adding another layer of filtering where if I know that my robot's turning at too high of an angular velocity, I just throw those scans out. I don't even feed it into the navigation stack, just so
Oh.
it doesn't get confused. I just
Mhm.
pretend up, no data available, because no data is better than data that it ends up confusing it.
Yeah. I think I was sort of stopping before I really used the navigate that data a lot. So I was moving and stopping and then letting everything settle down before I did another calculation about where to go. So
Do you think that maybe there's some latency in the overall raw stack and the intercommunications between processes? Because something I've found is that the Lidar and the IMU always update at different rates, right? So like what Chris was saying, what was the pose when this sample was taken, right? So if you add additional latencies in your system, by the overhead of ROS and, the stack communications, and I'm not that familiar with ROS, so I'm not really clear on exactly what it goes through. But I mean, even because, a lot of my stuff is pretty close to bare metal. I may have an RTOS in there, but I'm running pretty much straight up embedded code. So there's not a lot of internal latencies, but I see the same problems. I see that as you're rotating, the IMU is fairly slow to update. And I think that's part of the issue that y'all are trying to correct for. And like you've done, Mike, I'll slow that rotation down because the faster I rotate, the more that error gets generated. And I always see too, whenever, like when you're running Foursquare and you turn 90 degrees, when I start out, I always go to the right and then come back to the path. And I've always attributed that by, the IMU is kind of catching up, right? Everything's catching up with the IMU. When I went to the Beagle Bone Blue, and when I built number 9, other than the Linux overhead, that's a pretty beefy chip, and that's how. And without any corrections like what y'all are doing, I can hit a spot very, very consistently. Now, there's generally an offset to that, but I can compensate for that by just telling the robot go to a different spot of whatever the offset is. Now, what bothers me is I haven't been able to understand why I have that offset, but it's consistent. So I know I'm not generating random errors. There's something, and maybe you touched on it earlier, Mike, that you see this wheel slippage and the glitch. It's impressive you were able to actually measure that, right? But if it was slip or something more random like that, I would think that it wouldn't be consistent. And I see that consistency pretty much because when I run number 9 and Foursquare, I can hit a spot within half an inch consistently. Now, is it the exact spot I started at? No, it's not. Not without compensating for actually where the robot thinks it's going. But yeah, it's an interesting problem, and when someone figures it all out, let me know.
Yeah. Well, yeah, for 4-corner, I'm running really, 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 really slow, which helps a lot because there's not really a speed advantage for 4-corner. I guess if everybody got 1 millimeter off, then you bring in the speed as the tiebreaker.
Yeah, but timing can definitely factor in. I mean, I figured on my end that definitely there's a variable or two that I'm just not aware of or not factoring in, and it's just, again, it's an interesting problem. I wish I had the time to solve. It's almost like what I was always thinking, and it's kind of along the lines of something I've been wanting to do for a long time, is a rig almost where I can collect some ground truth in the sense that I'm picturing sort of this calibration rig, let's call it that, where I put the robot on and it's almost on a turntable that's controlled by stepper motor or some mechanism where I know exactly, right, at what speed I'm turning and then so on. And so I could generate motion on the ultra precise control, with not even dealing with encoders and wheel slip, but at least to generate this rotation and to then use that data, which, the hypothesis is it's more accurate, right? To figure out, okay, what's the lidar picking up when it's rotating this way at this exact speed, and I know exactly, my orientation of the robot at every sort of millisecond. My hypothesis is if you had sort of this precise data, maybe you could sort of calibrate the algorithm a little better, figure out what knobs to, turn in what direction in the algorithm. But I haven't had the time to do that sort of thing.
Yeah. This year in ROS, I'm trying to pay more attention to timestamps, because the navigator is supposed to interpolate and extrapolate timestamps to fix some of these delays in the stack. And last year I sort of set a lot of them to 0 because I shouldn't do that. And when it's at 0, it says, okay, it is what it is. Yeah.
There's actually a feature in ROS that's supposed to do exactly what you and I are trying to do. I forgot what it's called. I never got it to work properly, so I ended up trying to do my own thing. But you should know, I wish I remembered what it was called. There is something in ROS, a built-in package, a built-in filter of sorts.
Your own extended call filter.
No, it wasn't sort of Kalman filtering related. It was that wasn't part of the sort of keywords in there. It's some sort of LiDAR scan filter thing that's doing exactly that. It's allegedly taken into account all the timing of everything of the LiDAR samples, but I couldn't get it to work, so I kind of
that's point cloud with robot localizations, EKF, both local and global. But it's a lot of layers that you got to get right.
Yeah.
To get that all stood up, and it's a little bit compute heavy for some of the platforms that we're using. So that's what I'm dealing with right now. I'm working on outdoor navigation with GPS, and I'm about to give up on what I've actually finally got it working with robot localization, which is the standard ROS 2 approach up until like last September or something, when they deprecated it. Now there's another package called Fuse that they're trying to push, and but that seems to have gone off the rails. It's super active, and it doesn't handle like the RTK case very well. So I'm looking at another package called Fusion something, and I'm drawing a blank on it right now. But I'm hoping that'll have better long-term support for me. But it's been hell trying to get through the whole Kalman filters and all of the different frames that you got to process.
Yeah. I'm like, one of my big things is I'm forcing myself to use ROS, but I'm not sure why. I think it's just because it's a challenge. I'd probably do a lot better if I just did bare metal like Scott.
Wait,
but my outdoor robot can use a lot of the ROS stuff. So my whole thing is I'm doing it on the inside robot to learn ROS so that I can use it on my outdoor robot. So, but unfortunately, it's just not. I don't have any career goal, to learn ROS goals to improve my career because I'm retired. So, all right, I'm done.
Thanks, Mike. Chris, Scott, Kareem, thanks for providing some additional info. Hopefully, Mike can get things working a little better. I'm a little disillusioned that the Kareem mentioned that they're working on stuff to help it make it better, but it's got a very steep learning curve, and it seems to have been not much progress so far lately. So
Yeah, so
On Fuse?
yeah,
Seems to be pretty much done for indoors, but again, there's a real lag on addressing community issues. Haven't seen any updates recently, so it does seem like that was the designated successor to robot localization, the robot localization package, and it was sponsored by a company that developed it, but seems their focus is elsewhere now.
well, thanks, guys. Unfortunately, Trish had to drop off the call. She was going to report on her VEX robotics team's results from the last competition. Hopefully, we can hear about it at a later date, or maybe on Discord. But that brings it to the end of our presenters. So, does anyone else have something to present tonight?
No, just a passing comment, because on and off we talk about, code generation, GitHub Copilot and Cursor and whatnot, and Claude Code, and stuff is getting more expensive. We've talked about, and I've and others have recommended, hey, you gotta have at least one of those subscriptions. The free stuff isn't gonna cut it. GitHub Copilot until now has been a very good deal, actually, because for $10 a month you get access to all the good models and decent amount of credits to actually do useful things with. And they just recently announced they're changing the pricing model, because for $10 a month you basically were able to fire off 300 what they call premium prompts. But it didn't matter whether you asked it what time it is or whether you give it a prompt where it spins on for an hour. Right? So as you can imagine, as people get better and better in using this stuff, they're giving it bigger and bigger things to do with an individual prompt, and it'll churn on it for whether it's minutes or tens of minutes, and clearly that's they weren't making money, and then all these subscription things have been heavily subsidized anyway. That was kind of known, but it's just, unfortunately, GitHub Copilot is now going to more of a usage-based pricing. And I don't know yet what that translates to. I haven't been using it in my own personal subscription much, so I don't know if I would run out because I'm just too burned out from work, where I'm using it quite heavily. But it's just just unfortunate, because I remember I've been specifically recommended GitHub Copilot to some of you, who are trying that, and for $10 it was a good deal, and it'll still be. I think the pricing isn't changing, right? They'll still have a $10 tier subscription. I just suspect the amount of usage you can get out of it will be less. So we'll see.
Yeah, I tried to use the Copilot, the Claude 4.5, which is the free stuff, and for this motion compensation, and I tried to describe it clearly, but I said, here's my code, can you improve it? And it broke it. And so basically I said, look, you broke this, and it didn't, and you broke it, and it worked this other way, and then it came back and said, oh, you're right. So Oh, well.
Yeah.
I have a hard time describing stuff properly, I guess.
Yeah, but the other thing is, I know at one point I kind of semi-volunteered to talk a little bit more about how I'm using. I know, Karim is probably a level 10 out of 10 power user. I might be a level 8 out of 10, but it's I just haven't found the time. But I will say that, based on what you're just saying, is one of the key things you gotta do is you gotta give it the ability to test its output. That unlocks everything, right? If you are set up in a way where it can not just generate code, but also compile it and test it, you're golden. You just walk away. You just let it do its thing. So it's things like that.
Yeah.
Is once you get sort of to certain levels of setup, all of a sudden, there's a step change in how much useful output you can get. And also when you sort of let it just do its thing without asking you for approval, obviously it's kind of a little risky. But if you let's say either have it sandboxed or you just trust it, again, it makes a big difference. It unlocks just then suddenly that unlocks some actual productivity, because you literally just walk away and grab a coffee and come back and see what it's at. And but yeah, there's just a number of things you have to have set up, and it's not always easy in our space, right? It's more easy when you're doing Python on a PC, but when you're doing embedded stuff, to set it up so it can not just build the code, compile the code, but run the code, see what's happening, that just takes a bit of setup a lot of times. But just saying, if you had that, it would not break the code. It might, right? But it'll catch its own mistakes, and then it'll fix its own mistakes. And then you wouldn't have to be the one telling it, oh, now you broke it, and now you made it worse, right? You have to give it a way of judging its own output. Did it break it? Did it get better? Did it get worse? And if you have that, wow, you can get a lot out of it.
Yeah.
Chris, in the context of setting up an environment that can also execute, in terms of embedded hardware, what kind of an execution environment are you thinking of? Are you connecting it to real hardware, or?
No, on real hardware, yeah. I mean, I guess it depends on what you're doing, but it's, unless your code itself is so, the logic is so separated from the underlying hardware, and you purely just trying to get some logic right? Some math, right? I guess you don't have to run it on your real target. But a lot of the stuff we do, things are not always that cleanly separated, and a lot of times we do interact with the real hardware. So it's not that many examples where you could just say, okay, work on this algorithm in isolation of the real hardware. So I'm thinking of, give it a way to download the code to your hardware, run it, and observe if it's doing the right thing. If you have that, you can get a lot out of it.
Yeah, I found that I actually had to tell Claude to make sure it compiles. Because it would do something, and then I try to run it, and it'd have all kinds of coding errors, not design errors, but coding errors. And so I basically said, okay, and then it'll go through and run through a code checker and say, oh, I got to fix it, and it comes up with something that actually runs, but it might run bad, but it runs instead of erroring out. So that's an easy check. That's an easy check.
Yeah, and that's where there's nowadays, it's like Visual Studio Code, which is what I'm using, right, is moved from monthly updates now to weekly updates, and then stuff is happening at the pace where no one can keep up, in terms of how you can help these LLMs, do the right thing, because there's now probably half a dozen different ways sometimes to achieve the same thing, to basically tell it, okay, in this situation, remember to do this. In this situation, remember to do that, right? You can give it all these special instruction files. Some of them are set up so that they always get loaded. That's where you would put a statement like, before you wrap up your thing, try to compile it. And by the way, this is how you compile it, right? There's instructions that it needs to have literally every single time. There's ways to do that. And then there's ways to give it instructions that apply to when it's working in a certain folder. Then there's this whole skills thing, which is just instructions that apply to when it's doing a certain type of thing. Bottom line is there's so many ways to give it this additional, right, so that it does the right thing in the right circumstances. But it is hard to sort of get there and have this all set up. And I'm taking advantage only of core instruction file that gets always loaded. I haven't even experimented with these others, what they call the agent skills that get loaded when you give it a certain type of task to do. It knows, based on what I was just told by the user, I better look at this skill over here because it tells me, how to do this sort of thing. And so again, I'm not even maxing it out what's possible. It's just it takes a while to really get there. But I do know, even if you just take advantage of half the features that are there in something like Visual Studio Code, there's a big step change from not taking advantage of any of the features to taking advantage of some of them. A big step change in the kind of output you can get.
Yeah.
I will completely agree. That is worth the time to invest in the full stack. Full on my system, it can compile. It can read every single repo I have locally installed. It can compile. It can run code. I have very strict guardrails saying you may not run code that's going to move the robot, but it could move the robot if I let it. And it has done it exactly once, even though I had guardrails up. So I had to really maximize those guardrails in multiple places. And the skills, like every time you invest in like improving what it understands about your system, it absolutely pays off. Can't recommend it enough. And if you're into RAWs too, I'll share that Michael Wimble on HBRC, Homebrew Robotics Club, has recently published something like he's got a repo of like 157 skills for RAWs. Yeah, I use my own, but that looks like a very valuable resource, and I'm going to look at integrating it to some point very soon. But yeah, make it do the full testing, everything. Just don't let it run a 25, 26 kilo robot around your house. Yeah, that's a bad idea.
Sorry, I can't hear you, Mike. I don't know if it's just a mic.
You're muted.
So Ray, don't you do the AI, because you're giving a very detailed description of what to do? Is that you?
Yeah. I'm talking about what I do. Are you talking to me?
No.
Are you asking me?
Yeah.
Oh,
I try to
I'm asking
couple,
Ray.
Okay.
I guess, scripts that, just for kind of like repeatability, so that I would incorporate whatever changes into the script and just, rerun it. And, so,
because I thought you had like scripts that were 300 or 400 lines long, and it created about 300 or 400 lines of code or something.
no, my scripts I don't think were that long.
Oh, okay.
Yeah, basically just describing, in whatever detail I could think of to generate the code. But the other parts of that Chris says you should have, that was me. I'm the code downloader and the code tester, so
yeah,
I didn't use it to do that, but yeah.
The other thing that I find valuable often is, doing certain things in phases where, you get your rough thoughts on paper, meaning, text file and a markdown file, right? You just let it flow. You just, whatever ideas you have without worrying too much about anything, sentence structure, grammar, what have you. Then you let the AI do one cleanup pass on that, right? And now you have something cleaner, maybe just better structured, put things into sections, right? You're kind of trying to get all your thoughts on paper. You're trying to explain something, but now you're looking at a cleaned up version of your rough draft. And then you continue working on that cleaned up version. Right now, it's easier for you, right, to see. Oh, wait a minute, I forgot to mention this, and I forgot to mention that, right? Because it automatically categorize, put things into different sections, right? So then you're improving the cleaned up version of that explanation of what's going to become a big prompt, right? And then you feed that in, right? And so that way you can unlock a little bit more.
Yeah, that's kind of what I found. I could feed it a pretty good sized block of text, and it would seem very, to very concisely and accurately summarize what I had said, and took a lot less text to do it. It's kind of like, okay, yeah, that's what I want, So, but yeah, I guess I didn't think to start with that and then move forward. I just kept modifying the original script or file that I would send into it. So, but
It sounds like everybody's having sort of mixed results.
But Ray, are you still using just the free?
what? You froze.
He asked if you're still using just the free tools, the free AI
Oh
tools.
yeah, yep.
Yeah, we talked about that. Don't waste your time with the free stuff.
I'm cheap though, Chris. I don't want to pay these subscriptions.
You
Gemma
missed out on a
4
great
is
deal
pretty
on GitHub
amazing.
Copilot.
Say it again, Kareem.
Gemma 4 is pretty amazing, but in order to be able to run like the highest version of that model, you got to have a graphics card on your system. But if you got one, if you got a graphics card that has got like 16 gig on it of VRAM, run the second highest model, and you can run it entirely locally and for as long as you want, and it's close to frontier level.
Really?
They're almost competing on. They're almost competing with their own, and it's complete. It's completely open weight. It's completely free to download. So they're hoping that you actually run their cloud, and then you're just paying for compute as opposed to for tokens or for hours. But so that's one way you can do it. But you can run it directly on your local hardware. They got really compressed. You can use Windows for coding. Is one you can run on your local laptop even if it doesn't have high AI hardware. But yeah, it's pretty amazing. They're trying to fend off the sort of the Chinese open weight models. On there, try to keep the Google Cloud platform as just that's the easiest way to run the was it 32 billion model that they got in Gemma 4. You're still going to get better with the the absolute frontiers from Claude and OpenAI and Google too. But it's pretty amazing. Particularly,
I never tried any local.
It's worth a look.
Okay.
You can find videos all over the place on how to, play with it.
Well, thanks, guys.
Are we
I
done?
see Paul joined. Paul, do you
Oh.
have anything tonight?
Yeah, sorry to join so late, guys. We just had a contractor leave. But I don't know if you guys are interested, I actually do have something I can share. So this is a proto board for Moberry, the robot lawnmower, and so
Can somebody pin him? Okay.
Here we go.
So it actually sits this way, hangs from the back of the mower. So standard architecture, Raspberry Pi talking to an ESP32 on a protoboard with a ribbon cable connecting up to one of the motor driver boards that I got at the sensory sale, and an RTK GPS board here, and power distribution over terminal block, 28 volts in, 24 volts in, motor driver out. And so if you give me a second, I'll hook it up to Moberry and hopefully show it teleoperating.
And here comes the blue smoke.
I hope not.
No, don't jinx it.
That's what polarized connectors are supposed to prevent.
Yeah, right.
See a flash of light and Paul getting thrown back. No.
I guess you can put them in backwards.
Yep.
Okay, that should be ready to go, I think. Okay. So, see if we can orient this thing. Okay, so there's a little hanger bracket on the bolted to a couple of mounting bolts off the back of that are on the back of the mower, and the electronics plate, the backpack, hooks onto that hanger bar, and I've replaced the wheel motors with the ones that I got at the sensory sale. And so I'm just going to fire up ROS. So that's actually, just get the right windows oriented here. Okay, and see, we'll start up. Go to SSH. So what I'm doing is SSHing into the Raspberry Pi on Moberry and starting up the MicroROS agent, which is the intermediary between, it sits on the Raspberry Pi side of the serial link to the microcontroller, and it accepts microcontroller updates or microcontroller subscriptions and advertisements, publication advertisements. So it's just created a bunch of topics, and then I'm going to start up the joystick on my laptop. And with any luck, we'll go back somewhere. It's
It's alive.
Does your shag need a shave?
yeah.
Getting like one frame every 5 seconds right now.
Oh, really?
I'm seeing it move
Mine's
fairly well.
pretty fast.
I'm getting pretty good frame rate.
Maybe it's my end.
You've been cutting out a little bit, Kareem, so maybe
Yeah, your
Ah.
voice has been a little choppy.
Okay. Thanks.
So I don't know. It's that's it.
You got to put $10 into the meter for better
The meter.
connection.
Yeah.
So that's
Kareem,
great.
you're using
Darn you,
Teleop?
AT&T.
Teleop, yeah.
Yeah. So let's see. I'm going to share a window. So let's see. You guys should be seeing the system block diagram.
Yep.
Okay, so there's the Raspberry Pi running the Lidar Robot 2 software, and that's where I started the serial agent from. That talks over a USB serial to the ESP32 that's running MicroROS, which controls the PWM pulses that drive the DC motor controller, that drive the motors. I don't have the encoders hooked up right at the moment, or an IMU. But then off on my laptop, I'm running the joystick. The laptop is actually on my home Wi-Fi, so joystick ROS topic is getting published from the joystick app on my laptop and subscribed to by the MicroROS agent on the Raspberry Pi, which passes it on down to the ESP32. So that's it. I mean, I got to say, it's maybe not all that impressive, but I think the fact that it like took days to get this working is really quite gratifying. And that's what I think is one of the big things about Lidar Robot is it's so parameterized that you just put in some pin numbers that you want it to PWM on, and off it goes. You have a robot driving.
Yeah, I got a question about your micro or your MicroROS on your ESP32.
And the
The ROS times clock, the timestamp, does it synchronize its ROS clock with the ROS clock in the Pi so that the timestamps are good?
Yes, that's a part of what MicroROS does.
Okay, yeah. So you're timestamping it closer to the metal. So that's good.
Yeah.
How responsive does it seem? Is there significant delay or in you doing something on your joystick to the platform actually moving or?
You know, that's really hard to tell because, you know, it's a heavy platform, so it takes a while for the motors to spin up. I mean, yes, I perceive a delay, but there's a delay between when I start moving the joystick and when it hits the point where it actually starts sending motion commands. So you know, I really I don't think I can answer that question.
Yeah. So does it seem like, you know, fraction of a second or a couple seconds or?
No, it's real quick.
Milliseconds.
Quick.
Yeah.
Milliseconds.
Yeah, it's like tens of milliseconds or something. But yeah, for a simple ROS connection, topic connection. Yeah.
Yeah. So
That's good,
it's
Paul.
a short demo, but
Yeah. Now it's just code.
First star of the night, give you a black
Now
star.
it's just a lot of code now. Yeah.
Black Star.
hey, I get a gold star.
Gold
A
star.
robot moved.
Yeah. It moved.
Oh, excuse
Not
me, gold star.
autonomously.
Okay, I didn't know there was that restriction on it.
Gold Star's always been autonomous.
Okay.
Corrected. Gold or black star. There you go.
Thank you, Paul.
Yeah.
That's still significant progress. That's good. You've got it running, and
Yeah, get your gold next week.
All right. That's my goal. Autonomy by next week.
Go.
So the new control board, what is everything on it is probably like what, $350 or something? You got Raspberry Pi 5, probably ESP is nothing, but GPS RTK is probably $250.
that a Pi 5?
Right. I just have a Pi 4 on it at the moment, and you know, so Vlad says we ought to have a Pi 5 so we can run an LLM on it, and okay, I get that, but then how much memory? Because like a Pi 5, if you want to put 16 gigs on it, I was looking it up, it's like $350, and I was like, damn, that's a lot of money to
Whoa.
put an LLM that lets you say, hey, please mow the backyard.
Yeah. But once you go to Pi 5, you can put a AI subprocessor, coprocessor on it, on the PCI bus.
Okay.
So you get lots and lots of tops
Okay.
efficiently.
So Mike, have you looked at all at how much memory ROS uses?
Yeah, I have my Pi 4 here is like 4 gig and it uses about 3. Yeah, I had to turn my
okay.
swap on, and it uses a couple hundred gig of swap, a couple hundred meg of swap.
Okay.
I noticed that it was just acting weird, so then I noticed I didn't enable swap. So I said, because I have an SSD on it, so it's fast, and it made it much more responsive.
Okay.
With the SSD and swap. Yeah.
Oh, good to know, because this is an 8 gig Pi 4. And so I really need to think about 8 gigs as being a minimum, just to run ROS.
Yeah. Well, on your Pi, just run TOP, and it'll tell you how much it's using. Yeah.
Oh yeah, right. I bet I can. Well, yeah, but I don't have the whole nav stack fired up and everything. So
right.
Yeah, when I get that going, I'll do that.
Yeah. Mm-hmm.
And I actually had a question, something I was going to post to the list, but maybe you guys have some suggestions. It was I need to. Oh yeah. Has anyone played with the L1, L5 GPS modules, and do you have an idea of whether they work well and how much, how cheap you can get them for?
God, who was that played around with those?
I've got
Who was
one.
it? Tom, did you do that? Or was it Kareem?
Yeah, I've got one.
Oh, okay.
But apparently you can't hear me, so I'm not sure. Yeah, I've got one, and good, and you just can't get any support for it on RTK to go, so you got to have both the base station and because most of them aren't broadcasting L5 yet. L5 correct.
Good point. Thanks for that, Kareem. So you know of any?
And you don't want to do just L1.
No.
You can do just L1. You can, but you know, if you're getting anywhere near a building, it's good to have two frequencies.
Yeah, and also I did play with an L1 only GPS back about 10 years ago, and it took like 10 minutes to reach RTK fixed.
Mm-hmm.
So then a follow-on question, are there other good RTK GPS units besides the Z9FP that don't cost $280 plus antenna?
Well, the good ones are in the same price range.
Okay.
There's one that that is sort of immediate. I don't know on my head which one it is, but it's available at SparkFun, so you can sort them by price, and maybe find it was around. It was a good sized company, but their prices sort of come up towards where U-Blox is.
Okay.
And then there's the L1, L5, pretty much exclusively Chinese. They're good. They're just not ubiquitous. And yeah, there's that horrible overlap. Now there are some that are 3 frequency these days. So like the latest U-Blox, but those are even pricier. But so they can do L1, L2, and L5.
So what's the module?
If you go with
is it the ZF10 or something, or?
I think they skipped to 20.
Oh, did they?
Right.
Okay. I thought there was.
So if you go with 2 L1, L5 modules, what are their prices like for 2 of them?
I paid, so you know, with tariff and international and shipping and all that, I don't know what it is these days. I paid when I bought them, they were like $80 each. So total 160. I think they're higher now.
That's still a significant savings.
Yeah.
So I think I get mine from Waveshare. I got them from Waveshare.
I don't know. You have a link for it?
I'm checking. Option. No, that's showing 59. That's not right. Something. This is optional RTK.
That's just for the antenna lead.
It's only $60. Here, I'll share a link with you. That would be for the rover. It says optional RTK. The BS version. Yeah, it's showing up as $60. Here, I'll post it.
Yeah, I thought Doug had, I want to say some Arducam GPS units. I don't know where they are as far as pricing goes, though. And I thought it was the older L1, L2, L5.
And Sure has usually a substantial amount of product on Amazon, so you don't really pay huge shipping fees. Prices might not be the same.
Okay. Thanks for that.
Yeah, that's
And
the
then
one I got. And then the DA
and
is
then I
the
get-
base station. You'll see the right-hand side of the screen, you'll see the different variants. So you'll need a BS and a DA. That's also showing a 60.
um, and oh, I see. Yeah, and then you need an antenna as well. Have you?
Yeah, but they actually come with the antenna.
Oh,
Those kits, if you look on package content, you'll see that it comes with, it's a much smaller antenna than like the ones you get with U-blocks, but it's there.
oh, heck. Well, that
So
kind of
its
money.
sensitivity is not going to be quite as great, but it's still pretty accurate. I typically get 14 millimeters on my F9P horizontal accuracy reported. And I haven't played with this one enough to sort of profile it.
Okay.
Yeah, the price has come back down. It was definitely higher, and at one point it was spiked, so it was like over $100, like $99 for each. But it looks like it's relaxed again. Oh, but I didn't check on Amazon.
It's actually a couple bucks less on Amazon.
It looks like it'll sit right on top of a Raspberry Pi. Like using the connector. Thanks for this pointer, Kareem. I mean, for that kind of money,
Sure.
it'd be like, that's little enough to try it out.
Yeah, it's showing at $73 on Amazon. And if you already got Prime shipping or something, Prime account, then you don't pay any extra for delivery.
Right.
Oh, you do pay extra for delivery, but it's only like $4.40 for delivery.
But you fired it up and it seems to actually work.
Yeah.
And you fired it up in like you get an RTK fixed status report out of it.
Yes. Now, what I can't say is I haven't. So I just played with it to see if it would work. I haven't got it like set because it's like you need a ROS driver for it, and I didn't check to see if there was one. But when I was first messing with it, I didn't see a ROS driver for it, and so there might be one out there by now. I don't know.
Can it be made to work with other platforms other than Raspberry Pi? Or does it have to work with Raspberry Pi?
Yeah, you can write a node for it. I'm sure it's just a matter of I don't know if anybody's done it specifically for ROS yet, but it's not that hard to interpret. There are like the U-blocks node is just crazy in the number of parameters it is. It's like one of the longest things for me to compile. It's amazing how huge it is because they give you every way from Sunday to appear at every single layer of that thing, and it's just crazy. Getting it up and stable is it's not that hard, but they don't give you great road signs on how to done. I've been using it for a long time now, and I just haven't like bit off going that route with this one, particularly because I don't like maintaining my own base station outside.
Oh yeah.
So I can just pick it up and go whenever. but there's actually no
For sure, it'd
reason.
be nicer to use RTK to go. That's, I mean, that's great. But the price of this is pretty attractive when I'm like talking to the Moberry teams, advising them on what to buy.
Yeah, you let me know how it goes. I might jump on board if you guys start going in that direction. I don't know. There might be a ROS node for it.
I'll take a look. Awesome. Thank you very much, Kareem.
No problem.
Thanks, Paul. Thanks, Kareem. Anyone else got anything to present or questions tonight? Oh, Ray held up a finger.
No, I was just looking at something. Sorry.
So are we done?
Well, back in the baby steps section,
Tom's got something.
I'm making slow progress on building my my little gear motors for my much larger outdoor robot. This isn't, I haven't had power on this yet, although the sensors are tested. These are the screwdriver gear motors I've been playing with. I have a couple of identical ones, and that's a T5 geared pulley, and it now has an encoder on it. And I've been adding sensors, transmission type IR sensors. I'm comfortable with non-quadrature encoders, but I've installed two. Let me turn this sideways. I've installed two sensors on this, and I'll play around with whether I can get stable quadrature encoding out of it or not. So I built two of these things. I'll use them on a very large wheeled differential robot and see what happens. One of the things in passing I'll point out for those of you with simpler 3D printers, you can see in the background is my 10-year-old Prusa clone 3D printer, which I just love. When I bought it with automatic bed leveling, of course, which is absolutely the best thing to have. So the last time I manually leveled it was in 2017. And in the last several months, I've noticed the first layer has been deteriorating. So I got busy and learned how to manually level it again. It was out quite a bit. It was out about 0.8 millimeters across all 9 data points. So it's now down to about 0.15 millimeters. And the first layers are just looking beautiful again. So a little bit of a learning curve to remember how to manually level the bed on a 3D printer, but well worth it.
Yeah, it looks like you don't have the large, easy to grab. It was a thing that you could 3D print to basically make it mechanically much more easier to adjust the bed. Kind of a big, larger turning wheel, I guess.
The little handles you can put over top of the little tiny nuts, right?
Yeah, basically, yeah.
Yeah. Well, I experimented quite a bit yesterday and this morning to get it to the point where I was happy with it, because I was printing these little brackets to hold the IR sensors, and I was really unhappy with the bottom side. This is one, you probably can't see this in my camera, but let's see. You can see how messy that's looking. So the new ones look just gorgeous now, thank goodness. A big difference for an hour or two of messing about. That's all.
Yeah, I have an old Malon, I think it's a 150, which is kind of like a Ursa R3, I guess. And still chugging along.
Yes, I mean, it'd be nice to, drop $1,000 on a nice brand new 3D printer with state-of-the-art technology and beautiful finish, but I have no use for it. I just build stuff for my hobby.
Yeah.
And it just works. It's idle for months on end. I turn it on and it just works, and I'll use it for 3 or 4 weeks fairly continuously, and then I'll go do something else that doesn't need 3D printing. And it just sits for months again. It just works. I only
Yeah,
do
there was a
not
there's
significant.
this thing, I think it's called Part to Part. It's like kind of an industrial show that comes through every year. And HP had a let's see if I can pin myself here. I don't know, can I pin yourself?
I'll do it. Yeah.
Oh, there we go. Anyway, so HP's $5,000 printer, you know, it's this little cube and it's got like a locking mechanism. You open it up and whoops, that just locked it. You know, there's like a 3D printed hinge along with this, basically a latch mechanism on the underside of it here. And that's, you know, all printed at once. And it's like, yeah, for $5,000, you know, that looks pretty sharp, but
I'm sure that's good for something.
yeah. So I doubt mine would do this, but
Yeah, mine would be all locked up.
yeah.
Nothing would move.
Yeah, but the
Yeah,
first one
it'd
cost
break into it.
$5,000.
What's that?
The second one is only like $2,500 for the.
Oh, that's true. Yeah. Yeah. The cost, you mean? Yeah. But yeah, I thought that was kind of neat, but I don't know what the bamboos are costing. What are they, in the 500 plus range for the cheapest one?
I bought a PS1 back in February, and I think I paid with the AMS and the PS1 printer was about $1,100 Canadian, which would have been in the $600 to $700, I think, US.
Mm.
But that's not the cheapest one.
I can say that I'm able to print just about anything I put on it now.
Hmm.
It's made a whole difference in my print game.
When I was choosing what printer to get, I consulted with a friend of mine in Ottawa who had built himself an early version of a 3D printer several years before. Now, he doesn't use it anymore. He's bought himself a much more expensive high-end one, but he gave me his original just for laughs, and I'll show it to you. There it is there, for what it's worth. This is an original RepRap design, which I think he took great pleasure in building, but he says every time he went to use it, he would have to calibrate it and level it and fix it. He says it was a real nightmare. So I'm about to take it apart for the parts value. I don't think I'm ever going to try and run it. But an original RepRap design, apparently. An original Cruiser design, I think.
I think those designs are still supported. I mean, you can still get, you know, find Merlin software and run it on a Mega 2560 and, you know, the board that goes on top that does every single thing. I think you can get a processor to do to run your printer. But
they have them now. You can buy the board. They're fairly cheap on like AliExpress, an ESP32. That
oh yeah, yes, P32
has the little motor, has the position for the motor drivers that all the sockets and everything soldered in, and you can you know, you can buy them as well. You can add on the parts that you need for the complete driver.
Yep.
All right. Well, I'm heading out. Good night.
Well, guys, good meeting. Interesting topics tonight.
Bye.
Good night. Good night.
I'll see you.